Hey guys, Mr. LaHaye here. It's Monday, January 28th. Not going to be in today. I have a sick 1-year-old daughter. So still want to get the quiz in today for 7.2 and 7.3. Rather than going over a quick review there in class, I figured I'd make a little video here and you guys can watch this. The agenda for the day: to watch this video, and then I want you to take the 7.2, 7.3 quiz. I do not think it'll be too much of a problem. And then after that, I'd like you to read section 7.4 and do the book problems 1 through 15. So that's what will be due for tomorrow. And then I'll get that quiz graded. Before we get going on the quiz, though, I'd like to go over 7.2 and 7.3 again. Just to hopefully answer questions without being there, but just go over everything that you need to know one more time. First of all, with 7.2, that's where we had complementary and mutually exclusive and non-mutually exclusive. Easiest way to think of this: complementary means there's nothing in common between the two sets. If I have set A and set B, nothing in common, and their probabilities add to 1. That's what it means to be complementary. For example, if event A is rolling a 2 on a dice and event B is not rolling a 2 on a dice, they have nothing in common. One set would be 2, the other set would be 1, 3, 4, 5, and 6, and together their probabilities add to 1. That's complementary. Mutually exclusive, I'll switch colors so you can tell. Mutually exclusive means they have nothing in common. That's all. Nothing in common, but obviously their probabilities don't add to 1. There's something left out. That makes it mutually exclusive just because there's nothing in common. And then finally, not mutually exclusive, that just means they have something in common. Well, that wrote something. Something in common. Okay, so that's how you tell the difference. I want to go over the 7.2 worksheet again, even though we already did once. Just one more time, run through it. So let's take a look at this. Nine and 10, you're supposed to say whether they're complementary, mutually exclusive, but not complementary, or neither. Number 9, rolling a number greater than 2. That would be the number 3, 4, 5, and 6. Rolling a number less than 2. That's 1. Okay, so there's nothing in common there, but together their probabilities don't add to 1 because 2 isn't included. So that would be B, mutually exclusive, nothing in common. For number 10, rolling a number greater than 3. That would be the number 4, 5, and 6. B, rolling a number less than 6. Those would be the numbers 5, 4, 3, 2, 1. As you can see, they have something in common. Therefore, it's neither mutually exclusive nor complementary. That would be C. For number 11, rolling a number 4 or greater. That would be 4. Thing's not writing well. 4, 5, 6. And then B, rolling a number 4 or less. That would be 4, 3, 2, 1. Once again, 4 is repeated, so they have something in common. That would be C. Number 12, rolling a number 5 or greater. And we'll go orange. 5 or greater. That's 5 and 6. Again, we're talking with a dice. Rolling a number less than 5. That would be 4, 3, 2, and 1. Nothing in common, and their probabilities add to 1 because everything is considered. This would be complementary A. Hopefully that helps for complementary or mutually exclusive. Excuse me. Let me switch colors again here. The other part of this lesson has to do with finding the probability of an event or another event. So remember this equation. If you have the probability of A or B, that's the probability of A plus the probability of B minus the probability of A and B, meaning things that have been counted twice. Okay, so for number 13, there is nothing in common. I'll read through it. A pre-election poll suggests that the probability that the Republican candidate is 0.42, probability of the Democratic candidate is 0.47. Find the probability that a third party candidate wins the election. That's the same thing as saying find the probability that one of those two parties doesn't win. Well, think of Republicans as A, so that'd be a 0.42. Democrats as B, that'd be a 0.47. Obviously, you can't be a Republican and a Democrat. You're one or the other, so there is nothing to subtract out. This equals 0.89 when you add it. So the probability of a third party would be 0.11 because we'd subtract that 0.89 from 1, obviously. Okay, number 14 and 15 I think we went over in just about every class, but I'll speak on them one more time. For number 14, again, I'm going to get the equation on here. Probability of A, the stylus is not writing very well, plus the probability of B minus the probability of A and B. Okay, so for this one, aluminum, we're going to call that A. You have a 0.32 chance of that. We're going to call newspaper 0.47. That's going to be B. We have to subtract out the people that did both. 0.28 did both. That means we already counted them, so we have to subtract that out. Okay, 0.32 plus 0.47 is 0.79 minus 0.28. We have a 0.51 chance of somebody doing one or the other, at least one of the resources. Okay, and then we went over 15 in every class on Friday, so I'm not going to worry about that. That concludes 7-2.